The Mining Innovation Enterprise consists of a multidisciplinary group of students who are currently working on projects for NASA and other industry partners. MINE is dedicated to enriching college students' lives through education with hands-on engineering, science, and technology. MINE is working towards preparing their students to be knowledgeable in the aerospace, mining, and mechanical aspects of innovation, robotics, and automation in the mining industries. This includes future mining and extracting resources on the Moon and Mars. Our team consists of 30 people with varying majors from MIS to geological engineering. MINE is currently working on several projects. For the geological aspect of the enterprise, we are working on 2 projects: gypsum extraction research and deep sea mining. For the rest of the enterprise, we are building a competition robot for NASA's Lunabotics mining competition. The first project the geological team of MINE is currently focused on is the research of mining techniques and mapping the sea floor for deep sea mining. Deep sea mining is a new form of mining where deposits in the ocean would be collected for cobalt, nickel, manganese, and copper metals. These metals can be used in technology, energy, medical tools, and jewelry. Deep sea deposits include polymetallic and phosphorite nodules, sulfide deposits, cobalt-rich crusts, and gas hydrates. Currently, scientists know more about the outer reaches of space than they do about our own ocean's floors. Since the oceans cover 70% of the surface of Earth, researching the topography and geological processes that occur at the ocean floor could lead to important discoveries across many scientific disciplines. MINE is developing a remotely operated vehicle, or ROV, that would be able to travel down 400 meters. This ROV would be able to collect data, including geophysical properties, as well as collect rock samples for in-person testing. The goal for this project is to design and build the ROV as well as test it in the Portage River by the end of the 2020 to 2021 academic year. The deep sea mining ROV is meant to be a stepping stone towards learning new information as well as developing safe ways to mine deposits that can be found within the depths of the ocean. The other project the GEO team is currently working on is the extraction of water from gypsum. A future challenge to aerospace is the costly requirements of sending natural resources to planets and space stations. After gypsum samples were found on Mars, we have been working on a process to obtain water by taking advantage of gypsum's naturally occurring dihydrate form. With minimal chemical processing, this water can be stored. By using a water jet to liberate gypsum particles, MINE is experimentally working on the viability to net water from this cycle. We are developing a variety of nozzle types and configurations to determine the best placement, as well as testing on a variety of gypsum found on Earth. The liberated gypsum particles are passed to the calcining reactor that heats and stirs the gypsum slurry to release the water molecules. This process creates pure water and waste anhydrate. The necessary water production rate must be 120 grams per minute in order to collect the optimal amount of water between the 18-month launch windows. The next step is sending the water jet out at the end of this semester to have an enclosure made. The final project MINE is working on is the design and construction of a lunar mining robot for NASA's Lunabotics mining competition. The Lunabotics mining competition is a college-level competition that allows students to design, build, and test a robot that is able to excavate material on the Moon. Along with building the robot, there are presentations, systems engineering papers, and project outreaches involved as well. Our robot had to conform to a certain set of design requirements provided by NASA, such as the maximum dimensions and weight. During the first semester, our team developed and critiqued a multitude of different designs for the robot. We then held several design reviews where we voted for and against the different designs based on internal design variables such as operation cycle time, total weight, ease of manufacture, and so on. The design that was chosen uses what is called a bucket elevator to dig and collect the desired rocks in the lunar simulant. After selecting this design, all focus was shifted to optimizing, designing, and testing the different components of the bucket elevator. Our team was divided into 4 sub-teams consisting of the electrical team, chassis team, hopper team, and excavator team. The electrical team is focused on integrating the different servos, motors, switches, and sensors into a working system that can let the robot perform its mining cycle autonomously or via remote control. The other 3 teams focus their work on their particular portion of the robot. During the portion of the spring semester that we had access to the machine shops, some of the components were able to be manufactured and assembled. Much of the excavator portion of the robot was completed before COVID-19 shut us out. During this time that we cannot physically work on the robot, our team is writing a systems engineering paper to detail the design process. We will once again start working on the robot in the fall semester and should have an abundance of time to finish the robot as well as carry out plenty of optimization testing.